I eventually figured out a very clever trick. There's a roll-up feature called preserve modules. So instead of getting a bundle, what you get is all of the local files end up being compiled out as those local file names. So you get like a new tree in a dist directory of all those compile targets. So that really helped. And I realized I can point this script at my tests, and my tests actually import all of the relevant files in my package. So I get not only my tests cross-compiled that I can then test the CJS version of, but also that will automatically sort of in an automated way find all of my endpoints.
Wait, so Michael, are you saying that you added a build step to node development?
Yes.
What?
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by Rollbar. Move fast and fix things. Resolve errors in minutes and deploy with confidence. Head to rollbar.com/changelog. Request a demo. Get started today. It's loved by developers, trusted by enterprises, and most of all, we use it here at changelog. Move fast and fix things with Rollbar. Once again, rollbar.com/changelog.
Welcome everyone to JS Party, your weekly celebration of JavaScript and the web. On today's episode, Mikeal and Chris are joined by Fred K. Schott. Now, you may remember Fred from episode 69 on Pika. This time, he's here to talk all things ES modules. Let's get straight into it. Hey, it's party time, y'all.
Hey everybody, welcome to JS Party, where it's a party every week with JavaScript. Let's get into it. We're going to talk about ESM today. So what is ESM, and why do we have so many acronyms for things instead of just talking about them like regular humans? Fred, tell us about ESM. What's ESM?
Oh man, ESM is everything and it's nothing, and it's not a big deal and it's a huge deal. It's a really cool technology that I'm very excited about.
Sounds like JavaScript.
Yeah, like JavaScript, it's both a toy and changing the world at the same time. ESM is really just a way to like load JavaScript. So yeah, really a pretty simple concept, but it's a concept that works really well on the web, which is something that we haven't really had up to this point, which is amazing on its own. It kind of takes the best parts of the web where things are usable by the browser and they're URL based. So the browser knows how to cache things and load things and kind of load everything you need at once in parallel. But using all the things that we've gained over the last decade, really, of having a module system that, is built on a registry that is huge and growing and popular. You can bring your tools. You have a really explicit connection to how your code is loaded. It's kind of all the best of everything we've gained over the last 20, 30 years of development.
Yeah, and I think, for people that are relatively new to software development, your comment about, it works well for the web is probably not all that well understood, right? If you've been doing web development for less than 10 years, you're probably used to I use NPM and I use these compilers, and that's part of the web development experience, a part of the web. I think people forget that there's this time period called the 2000s. And in the 2000s, we didn't have those things, but there was some really cool stuff happening on the web. And the way that you loaded things on the web was with URLs. And so the first thing you did was load jQuery, and then you could actually program.
And that was your whole package ecosystem.
Yes. And so you would put a script include in, add an URL, and it would just pull in things out of the web in the browser. It wasn't running through a compiler. We were just kind of pulling these things into the browser just in time. And we kind of built from there. And that was before this whole kind of compiler ecosystem happened, because the web never really had a module system. This was, in the dark ages when everything was using var and, all of that.
Shudder.
Yeah, did you forget about var?
I have a talk that I give where it's a slide, and every time I go to it, I get a gasp reaction of just script tag. The way you loaded code was just kind of throw it on an HTML page and hope that your order was right. Hope that these things knew how to load each other implicitly. and that they would fail if they didn't. It was a pretty wild west of programming.
Yeah, on the one hand, you had this dependent ordering to make sure that things were injected into the scope at the right time, but that also meant that you had to load those in that order and that you couldn't do it concurrently and efficiently unless you added other tags, and then you had all these extra dependencies, and it was really a mess. And to some extent, this whole compiler ecosystem that really it definitely predates React, but React was like the first web framework that was not a script include. Like even Angular was a script include in those first few versions before it moved into this kind of compiler space. And then with React and then kind of everything that came after it, the web frameworks and our web tool chain was all implemented as a compiler and part of a compiler tool chain. And you weren't really using just the web anymore and just the browser. And what ESM does is that it takes these primitives that we have in Node, like the module system, and this way to package up a program and give it to other people and let other people rely on each other's programs and build these dependency chains. It finally gives those primitives, at least, to the browser so that now I can, use this module system and depend on other people's stuff, like effectively at URLs and things like that. But that's a pretty disruptive change. We have more than 1 million packages in NPM. It is I think in order of magnitude, the largest package ecosystem in the world. And this is all not really working on that. So
yeah, it's a huge change that feels very small, but it's so fundamental.
And I was just going to ask you sort of some of the early Pika stuff that you did was really looking at okay, well, what is an NPM that is an ESM? Because a lot of people have been using ESM and packaging stuff up with NPM. And so what was sort of the easy to translate layers of this existing ecosystem, at least for browser developers, to move into ESM that's already in Node, and then where are kind of some of the compatibility problems already?
Yeah, it's a really interesting, the way it's kind of come into the ecosystem is really interesting because it actually was a pretty nice, there were a lot of things to like as an application developer for ESM. So using it in your application, you were no longer using this require function that Node had kind of adopted and that web developers just brought on as a force of habit and a way to work with NPM. You got this much more friendly and much more easy to analyze just method to import and export. So bundlers were a little bit more efficient when you wrote your application using ESM. There were just a lot of things to like as an application developer. The problem was that then what people were doing was they were almost downgrading the things that they published to NPM that they shared with the world from this ESM to this common JS. So going from a really explicit, newer import export to just that, that module.exports, that require function, the code that runs on Node, even if it was something that they were building only for the web. So it was this kind of a downgrading almost of fidelity, right? And you can no longer analyze really easily what it has and what it's exporting and what it relies on. Mm-hmm. So there was this weird problem that we had where we had the technology, application developers were loving it, but then everything that we were relying on, which makes up 90% of most web applications, Node applications, it's a huge chunk of what we end up running, was this lower fidelity, this downgraded experience.
Yeah, and sort of to put some more specifics on that, I think, people have thought that they were using ESM for a long time because they were using this import syntax and this export syntax. They weren't actually using Node's require function. But the thing that I think nobody really realized in doing that, they weren't using the browser primitives for that module system yet, right? Obviously. But they were also relying on a lot of things that compilers were doing that were actually not going to be practical for browsers to do in a native ecosystem, right? So one of the things that these compilers did was if you imported a package by name, it would use Node's resolution logic for Node's module system to go and figure out where that module is by that name. This is one of the big things that kind of breaks in native ESM is that these things have to map to files. The browser can't go and check a bunch of areas and directories recursively to figure out where the root of a package is, right? So it either needs to have directly a link to the file, or it needs to have a name that then there is an import map, which is another feature in ESM that we might talk about later, that maps that name to a specific file. And so, for tooling authors, this is kind of amazing because now you have this statically analyzable module system that you can, pull in and just look at the syntax and kind of know what's going on. And each of those things are not pointing at a complicated resolution logic. They're just pointing at a file when you're in this native space. But for the compilers that have kind of taken all of the old Node code and made it work in this ecosystem, a lot of the work they did kind of shielded people from how dramatic of a change this is actually going to be once we start to really move to native ESM. Like we actually have to get rid of a lot of that stuff. Some of that stuff isn't going to work anymore, or we're going to start to do, we'll talk about some of the nasty compile stuff that you have to do to get out of this world a little bit.
Yeah. I think I have definitely softened my stance there a bit in that when you looked at this kind of in the early days of everyone's using Common.js and we see the world shifting towards ESM, but there are these like kind of still hairy things that we need to work with. So like, I want to import something by name. I want to import React. The browser wouldn't let you do that. It would say, React, what's React? I don't know what that is. I don't know where to find it. Poo-poo to you. It would die. Mm-hmm. I think I see the middle path here that will, whether that ends up, like, there's a world where we don't actually need that in the browser. There's a world where you still get all the benefits of developing with ESM. Whether you're a library author or an application author, we're already coming from a world where web developers use tooling to kind of sit in between what they're writing and what ships to the browser. So we're moving to a world where that can be much lower cost and much lighter touch. You can rewrite at build time, essentially import React. Okay, well, actually, I want to import it from here. There are these things that seem like limitations of the platform, and they definitely are, but they aren't blockers in that way, where tooling that we're already relying on can both simplify itself, become lighter touch, but also take care of these last few issues that exist, these last few things that might be blockers, but can just be solved by tooling. That's really where Pika and Snowpack and Skypack, where all these projects that I've been working on come from that idea of just what would tooling look like in a world where we have these much easier to work with primitives, module system, et cetera.
Yeah. And I've been really happy to see that tooling in that ecosystem really starting to take a lot of these problems quite seriously. So not just sort of supporting the things that Node is doing, like export maps, for instance, which is a feature in the Node module system that's kind of important. And now compilers will look at that and have an understanding of it. But also like compilers, like all the new versions of compilers and even Rollup now have basically taken the stand that they're not going to inject Node polyfills anymore, which is something that, we got really used to all of that tooling just kind of doing automatically and not really seeing the cost of, using the buffer interface or using all these Node.js standard library modules.
Yeah, all of a sudden you were looking for one hashing function and you installed the entire cryptographic library of Node into your web application. It's like, why is my web app a megabyte? It's like, oh, that's why.
Yeah. It's pretty bad. I've been dealing with just removing just buffer from my code, like just buffer from like our libraries and our dependencies. And honestly, at first, it wasn't even migrating to uint8 array. It was just importing buffer as a module instead of relying on the polyfill, because the polyfill was going to break in all these compilers. And that took months, like hundreds of PRs. And, we have a much bigger change going now in the same stack where we're actually migrating to uint8 array. And, changing out a value type is one of the most destructive things that you can do in these ecosystems. So it is a bit of a painful upgrade. But before we sort of set this down, what are the benefits? Like, what are we going to get out of this other than just the pain of migration?
Yeah, I mean, I'd love to talk about some of the stuff we worked on. I mean, Pika started as a way to find these packages. This idea that right now NPM search is very node focused. And you can think of NPM as, it started as Node Package Manager. The whole ecosystem has had a preference for Node, I would say, and not really been about what do web developers need from it. Webpack, Rollup, all these things existed to basically take that ecosystem and make it work for the web. So it was very much take a thing that is built to run as installed on Node and now do things to make it work on the web. It's a subtle point, but it's a really interesting part of the model that we all have built on for the last 10 years.
Yeah.
The realization was that this was a big change for kind of evening that playing field, and that like now ESM as a module system is something that everyone can rely on. And that what that means to make this work for the web is actually much lighter touch. So when you have a module system that you can ship to the browser, if you think about what Webpack does, especially when you're doing development, you hit save, and what Webpack has to do is take that one file change, now integrate that into these bundles that it's created, recompile, rebundle, reship to the browser. What you end up with, and I've seen this myself, I know if you've done web development, you've probably seen this yourself, this idea that your dev server takes a long time to start up. When you hit save, it takes a long time to react to that change. There's cool things you can do with HMR, and then if you've heard of React Refresh and all these different projects to kind of shorten that cycle. But at the end of the day, what you're looking at is I've changed one file and now my dev tool has to go and change a bunch of files. And that's just built into the model of bundling, by definition of bundling. And by definition of what Webpack, Parcel, Rollup, what they're all doing is they're following that model. What I've started experimenting with Snowpack is just a different model. So all the same build tools, you still use Babel, TypeScript, everything you're using today. But the model is changed, the underlying model. And what that says is that when I do development, I actually stop using a bundler. Because I have ESM, which works in the browser, I make a change to a file. And now all I need to do is rebuild that one file. So instead of rebuilding lots of files, recompiling, rebundling, and then shipping that to the browser, it's, how fast does Babel build a single file? Pretty fast. And what that also means is that for caching, right? Bundlers have done a ton of work to create a really smart caching layer. But at the end of the day, again, when you're combining all these files together, your caching is just kind of lower fidelity because multiple files are combined. You change one, you change them all. What we're able to do is that once that file is built and cached, because it's only one file, you never have to rebuild that file again until you change it. So the caching story for Snowpack as a dev environment is that basically every file is built once and once forever. And then as you make changes, you rebuild. And if you change a config, you rebuild it all. But the savings that you get on the second run, the third run, the fourth run, the startup time is essentially less than a second, down to 50 milliseconds for most people, because all that upfront work of combining files together and bundling, you don't need to do that anymore with ESM. You have a browser, a module system that the browser understands. So you can just kind of ship it. And Snowpack exists to just, again, like Mikeal had mentioned, there's a few little things that it has to do other than building just to make this run in the browser, but it's really light touch.
How does that work with, say you're consuming a library that uses CommonJS? So what do you have to do to support that?
Yeah, so that's smack dab in the middle of our problem space, which is revisiting that question, what does tooling look like for a world where you're ESM first? The one thing we need to do is when you import React, we rewrite it to a URL, so a place that we are now hosting a React package. And then what we do is React is CommonJS, so that's actually a great example for this. What we do is we actually look at, okay, you're writing ESM. So your files, they're the ones that change often. We'll have this really light touch dev workflow where we rebuild and resend single files to the browser. For your dependencies, those actually don't change that often. So what Webpack and others are doing today is they're rebuilding entire chunks of your application every time you save a source file. But what we're able to do is say, that CommonJS thing that we still need to handle, once you install it, it doesn't change. So we can actually, essentially what we're doing is we're bundling that one dependency. We're converting it from CommonJS to ESM one time as an install step, more than a build step or a dev step. It's a one-time cost that then gets reused until you change your dependencies again. So we handle it as we're ESM first, but we have this CommonJS support where we just turn it into ESM. And that's something we do once, and now it's saved in your project and reusable forever.
That sounds like a non-trivial problem to solve.
Yes. Snowpack has existed for almost a year now. So it's not something that we've just kind of stumbled into. The first version, that was all we focused on, was you tell me your dependencies and I will give you essentially, what is React? It's many files kind of combined together. What we would do is we'd take React and give you a react.js. We'd give you a single JS file, an ESM interface, and it would be runnable in the browser. The idea there is that that's the problem to solve here. And once you've solved that, now you are essentially an ESM-only dev environment. All of the files you're working on are ESM. All the files that you're serving to the user are ESM. And you can start to do some really cool stuff once you're relying on that assumption.
What up, JS Party people? It's your boy here, Adam Stacoviak, and I have a question for you. Are you having trouble uncovering performance issues in your Node.js apps? If so, check out our friends at Schott APM. That's scoutapm.com/changelog. Schott is application monitoring that automatically reports key Node.js monitoring metrics, instruments many Node.js libraries automatically, detects easy to miss N+1 queries that sneak into production, plus a ton more. And of course, Schott is easy to install via npm package. Learn more and get started for free at scoutapm.com/changelog. No credit cards required. That's scoutapm.com/changelog.
Okay, so something that I have been doing is trying to port a lot of my libraries to native ESM. Particularly, I have a set of new libraries that are really the foundation for a kind of stack and an ecosystem that we're building. And I really don't want it. It's going to be very hard to move that to ESM later after a lot of people depend on it and there's a lot of ecosystem on top of it. So I really want to do that now. And so I've really been struggling with a lot of the incompatibilities in native ESM, particularly in Node.js. So, it's been very easy for me for a long time now to write a library that works in Node and works pretty well in browsers through compilers. Like I can, if I'm using require, everything just kind of works. If I limit my dependencies and stuff, I know how to kind of limit the tree and things work out like relatively well. There's definitely a bad way to do this and a good way to do this. And I found like kind of a sweet spot. When I started going to native ESM, it was like, everything's broken. So to talk about some of the compatibility differences, I should start with some of the history here. So Node has a module system because we didn't have one in the browser. It's the same reason why it has its own buffer API. There was no binary API in JavaScript yet, so we had to invent one. And when NPM was created, Isaac started working a lot more on Node Core and in fact took over the module system. And so Node's module system and NPM kind of co-evolved together. And the resolution algorithm inside of Node actually came from NPM, and these kind of play on each other. And if you look at where compilers are today, you can see that they all kind of started with Browserify. And the take there was like, okay, I have all this code in Node, like how to make it work in browsers. And so Substack wrote this compiler called Browserify. And it is very much like from the point of view of a Node person that wants to get things on the browser, not a browser person that wants to get things in Node. I mean, Substack is really like the sort of philosophical center of like the small modules philosophy around like in the Node.js ecosystem.
Yeah, what is he up to in terms of module count now as an author?
Oh, it's got to be over 1,000 at this point. I mean, there's no way that it's not over 1,000 because he was doing like about 100 a year for like a while. In some years would be more, but yeah, it's way up there. But he's actually writing a lot more Rust now, so I think that it's probably like come down a little bit in recent years. Anyway, like, from there we started to get other compilers, and all of these compilers leveraged Node's module system as the sort of like way in which you packaged up these little packages and then brought them back in for use in the compiler. And so even as front-end development became 80, maybe more % of what is actually in NPM, the usage of NPM, like if you look at the numbers on this, like front-end actually dominates this ecosystem and back-end is like not as big. Backend in Node is bigger than backend in most other languages, but this just kind of shows like how big web development is and how big JavaScript is compared to a lot of other languages. And so the tooling has always had this very kind of Node-centric like view of the world. And one of the challenges that they had when they were building the module system, like the ESM in the early days, was like, you can't really reconcile a lot of the decisions that were made with what needs to happen in the browser. Like you can't have a resolution algorithm like that. Like you have to just point at a file. Like that's not going to work for us. A lot of the things that you need in the syntax to make it statically analyzable are important to make it fast in the browser. And so these things weren't very well reconcilable. And to top it off, Node was in a very bad position as a project to be able to actually communicate and to work well with standards bodies at that time.
This was 2013, 14, 15?
Yeah, exactly. So it was before the IO.js fork, before the foundation. Node just didn't have the capacity as a project to really participate well. And so a lot of changes actually did make it into ESM, and people like Yehuda Katz did work to make ESM easier and more compatible with Node, but nobody who really understood the complexities of Node's module system were there. And so a lot of things were ratified before we had figured out how we would actually deal with compatibility in the future. And everything was really locked down and really ratified. This was also before TC39, the standards body doing JavaScript, changed a lot of their processes. And so it's actually like a much better kind of staging process, and you need a lot more implementations to get through to the stages now. This was one of the last things that kind of passed in the old process. And so it's just been a real nightmare to try to get this into Node. I think that the effort has taken roughly 4 years to figure out and get unflagged. And there's just been like so many complications and compatibility issues. And so at this point, like the trade-offs that are there are somewhat permanent. And there's some things that are never going to work. So when you are writing ESM, you can import something that is CommonJS, and Node will figure it out and kind of give you a module back. If you are using require and you try to require a module that was written in native ESM for Node, it will fail. So this is a one-way migration that you make. And if you just publish a package that's just native ESM with nothing else, it's not going to be usable by anybody using require. So that's really painful. And this was one of the first kind of things that I dove into. Eventually, with kind of some help from Miles Borens, I figured out a way for Rollup to actually generate a CommonJS version of the package and all of the package files, individual files. And then you can use this thing called an export map in package.json. You can look up that feature if you want. And this is how you say, like, here's where the import file is that's ESM, which is like the regular file, and here's the one for require. So when you require this, like, don't fail on the ESM version, here's the CJS version. So now there's like this sort of build step as part of all my stuff that's using this export map. And that worked well for Node compatibility. I eventually figured out a very clever trick where there's a rollup feature called preserve modules. So instead of getting a bundle, what you get is all of the local files end up being compiled out as those local file names. So you get like a new tree in a dist directory of all those compile targets. So that really helped. And I realized I can point this script at my tests, and my tests actually import all of the relevant files in my package. So I get not only my tests cross-compiled that I can then test the CJS version of, but also, that will automatically sort of in an automated way find all of my endpoints.
Wait, so Michael, are you saying that you added a build step to Node development?
Yes.
What?
I mean, like, if you just want to say, screw you, you got to use import, you can't use require anymore, you can avoid this build step. But yeah, Node people now, if they want to maintain compatibility with the old world, they're going to have to suffer a build step the way that browser people have done for a long time.
Yeah, that's a really interesting part of this, right? It's that web developers had to make this compromise, 7 years ago or 5 years ago, whatever it was, where, okay, you know what? To make the ecosystem work for us, because it is not compatible or because there are inconsistencies, we are going to add a build step. So now it's so funny to see this, because now the web is saying, great, we get a lighter build step. Mm-hmm. But Node is having a very different conversation, which is, what does it mean to handle these inconsistencies? Do we have to build them into the platform itself? Or can we follow a path that you're kind of following, where in user land, you add essentially just a layer in between the two to handle these inconsistencies for you?
Mm-hmm.
I don't know what's the right answer, but it's very interesting to see for the first time, like, the web is actually able to move in a direction that feels natural, and the Node is having this kind of come to moment where they have to decide what they're going to do.
Well, and Node is very concerned with performance and very concerned with trying to keep the platform relatively thin. And so the one thing that Node will not do, and there's kind of a line in the sand on this, is that it is not going to cross-compile your code. It is going to run your code in V8 the way that it looks to it. And the most that it can do is try to create a compatibility layer. There's a package by JDD who wrote Lodash called ESM, and you can literally import this in your program, and it will basically cross-compile every ESM and CommonJS thing that comes into it in order to make all of these compatibility concerns go away.
Right. It's like a TS node or a Babel node, one of those things that makes code run on node that shouldn't run.
It is very impressive that this hack can be sort of built upon to make all of this stuff just work, but you do lose a lot of the native parts of it. Like, the whole point is to kind of try to migrate to this native experience, and you're definitely not doing that when you take that route.
To be clear, you have to require ESM. You do not import ESM.
Right. Yeah, I should have said that. Yeah. You cannot import it because the hooks that ESM is using in the module system to do all of this cross-compatibility stuff are deprecated in native ESM. So the moment that you're in an ESM mod...
And this is ESM the package.
Yeah. ESM the package. So you have to require ESM, and then it can add all of these hooks. If you tried to do that in the new native system, because one of the things that happened in this transition, right, is that the module system is not implemented by Node anymore. It's in V8. It's in the language, right? So we don't have the ability to give you userland hooks to just like go and do all your like YOLO crazy. Like you've got to, like, you can do that in the old require stuff, but you can't do that in ESM anymore. But yeah, like that, there's been good work here trying to deal with this stuff. But yeah, once you move to native, then you have to compile. But before you get too on your high horse about like, oh, like now you're doing what browser people do, it also still sucks for browser people, because Webpack has opinions, I guess. And one of their opinions that they've had for, I think the oldest bug I saw was at least 3 years old. But Webpack thinks that when you do export default, right, which is the default export thing that you do in ESM, that should not turn into a representation to CommonJS that looks like a default export, like a module.exports equals, right? They have the view that when you do this transition from ESM to CommonJS, that should just be an object with a default property. And this opinion is shared by literally nobody. So Webpack does that, and that's in Webpack 4, and Webpack 5 is going to be in beta for quite a while. And I don't even know if they fixed it. So yeah, that means that you run into this other problem where I publish this module and it works in Node and you can require it in Node. So you get your program up, you npm install my module, you require it. It works, right? Because I did that cross-compile step. Now you try to run Webpack on it. And what Webpack is going to do is it's not going to find the require stuff because it doesn't know anything about export maps and that whole require thing. It's just going to look at the import and, just at the regular files in the tree. And those are going to be ESM, and it's going to do its ESM changes to it. And so the representation in Node and in Webpack is going to be different. It's going to break. So that sucks.
Hooray!
Yeah. Webpack, loves to listen to people when they have, anyway. Okay.
I always get sensitive to this myself because I think when I say, that Snowpack is a different model, I think people say, oh, so what do you hate about Webpack?
Mm-hmm.
What's wrong with that? It's just a different, right? It's like they are coming from this world where you need to make everything CommonJS-y.
Mm-hmm.
And in that world, why wouldn't I want module.exports to be the thing? Why would I want like a secondary default?
And more than that,
they have their mental model. I don't think it's the correct one going forward. But I see where they're coming from just based on their 10-year history or whatever, however long they've been around.
This is sort of my view of it and kind of where I come from. When you're dealing with these cross-compatibility concerns between different systems, it's really important to agree on representations in these translation layers, right? Like what you're really talking about is like two completely different things that you're translating from one representation to another so that they look the same. And it's very important to agree on that and to agree with other parties other than just your own project. And they probably really made the right decision for their internal primitives so that their import function can operate identical to the import syntax. That's what that's about. That is probably, the right decision, for their plugin ecosystem, but it really breaks compatibility ecosystem layer when you think beyond just Webpack as a project. So the fix for that is another compile. So one of the nice things about newer compilers, so new Rollup and Node.js, is that they look at this export map, this new feature that tells you sort of for all these different endpoints in the package, what files do they map to, and can they map to something different for the browser, for require, for import. But old compilers like Webpack 4 and before don't even know about that property. Browserify doesn't know about that property. They're going to look at this old browser property instead. And so what you can do is you can fill that browser property up with another compile of the CommonJS compile like you did for Node, but just targeted for browsers instead of Node. So now you have two compiles that are now in your tarball.
Oh boy.
Which are super fun.
Yeah, using deprecated fields intentionally to solve a problem is my favorite solution.
Yes. And just managing all of the fields is a sufficiently complex project is like kind of a pain. So I did write a little project that I named Limbo because I really hope that this is the temporary state of limbo that we're in between these two systems. I would encourage people to look at and improve and use this module if you're trying to write native ESM libraries. But the intention of it is to eventually die. Like, I really hope that someday we do not have to use this library. I very much look forward to the day that we deprecate it. But right now, there's a project on my GitHub called Limbo that you run it in your package. It generates a dist with all of this stuff. And you can run it with a -- save option that will also fill out the export map and the browser field for you, because that gets really problematic over time. But one of the cool things about that is that after all this is done, I can run all my tests in native Node ESM, just using Node test stuff. I can then run as a test target all of those CommonJS files that I was doing before, and then it'll use all the CommonJS version. And I can also target all those browser ones, and it will work with like an old Webpack in older browser test utilities. Like I use one called Polendina that Rod Vag wrote. And, Chris will like it. A lot of this stuff is actually using Mocha behind the scenes for a lot of the older stuff as well. And maybe I'll talk about new testing stuff if we have time. But that's kind of how all that stuff works.
Testing NESM is a very interesting story.
Yes. I hate to do that last because I'm sure that Chris will have really good things to talk about. But yeah, so that's the state of like what you need to do if you want to write native ESM and have everybody be able to consume your library. But there's this other story where relying on Node's module system, and not just in Node, but in compilers, is increasingly problematic in a native ESM world. Even if you're converting these native files, like you are constantly being presented with the complexity of your dependency chain because you're seeing it a lot more visibly in this native ESM world, and it gets more and more problematic. And so sometimes what I want to do is actually not npm install a package and required and let all these systems figure out how to get it. What I want often is I just want to take something out of npm and just bundle it into a local file that I import like any other local file. Sometimes like that is the best solution to some of these problems, to just kind of quarantine this old npm package for a while rather than relying on this very complex system that is rife with sort of surface area for bugs.
Are you talking about vendoring it essentially?
Yes, exactly.
Okay.
I wrote a package called burp, BRRP, and you give it an npm name and it will just bundle out, it'll actually install in a temp directory and then clean itself up, the package, and then bundle it up as ESM. And you can target either Node or the browser, and you can, even use it to cross-compile and add a CJS version if you wanted that bundle for some reason. So that's another kind of interesting tool. NPM is successful because it did such a good job at hiding that dependency tree from me. Like I don't have to think about how nasty it can get and how many like old dependencies and cross dependencies are in there. And for other reasons, as I'm being presented with that complexity and I can't ignore it anymore, it's just the node module system npm install workflow is just not as nice anymore. It lost a lot of its kind of shine. I have to see how the sausage is made.
Yeah.
It's as bad as you would think, right?
It feels like specifically you are, I think, starting to realize, or I tell me if this is a fair representation, that this migration is going to need some help from the tooling ecosystem, even for Node developers.
Yep.
That the idea of a whole ecosystem moving in lockstep from one module system to another is not going to be easy or just something that can happen naturally, that there will need to be some sort of limbo state. I think that's a pretty well-named title of a package to handle this kind of transition.
Yep. And then, so I will talk real fast. I know that we're sort of running out of time for the segment, but I do want to talk about testing a little bit because I think it is, as a library author, it's one of the key benefits that you can see getting out of native ESM, where the testing infrastructure can get a little bit nicer. One is that we just have like a nicer kind of primitive for a module system. So thinking of a module as a test and as something that you can, not just like a file that you run and you have to inject a lot of environment around, but really like almost like an object or almost like a data structure that you can kind of pull in and poke at. So something that me and Fred have talked about for a little while now is like, if you had a test format that was somewhat framework agnostic, you could actually pull those tests in and then update a depth tree and then run the tests for your dependencies against, with your new thing in the depth tree really easily because you have this kind of componentized system. So I started to write that because testing in native ESM is also really nice. Like not having to bundle anything, or at least not having to bundle your local files in order to get things running in the browser opens up a whole new vector of like really nice testing that you can do. So I started working on something called ES Test. And I have it running in Node and in Dino, actually.
Oh.
And and I'm about halfway through the browser one right now. But a couple features of it is like, one, once I'm running tests on like a million platforms, because I also want to use this eventually to test a lot of the cross-compiled stuff. So these are taking too long to run. So I need everything to work concurrently. And so by default, the test format is concurrent. And you can set the concurrency to 1 if you know that this test can't work concurrently. But having things work concurrently by default means that I can run all of the tests for all these environments and all of those tests in those environments all concurrently. Like if I have 8 test files, I can run them in 8 tabs in the browser. And even as those tests get added inside of it, they can run in parallel if they're doing async operations. Like it's really important once you have like the number of tests that I have that stuff is really nice. But also, the test format itself, you don't have to import anything and you don't have to have any globals injected into the file's environment to run the test. It literally, you export a function or you export a bunch of functions and they take this test interface as their first argument. And tests are just async functions. They either throw or they pass. That's it. There's no additional sort of state to manage because in this native ESM world, now that we have async functions, you don't have to do a lot of Chris probably knows this better than anybody, like a lot of the like stepping and setting up an environment and tearing down an environment, and a lot of that complexity, a lot of that is really related to the way that the old callback system worked, and the fact that, it was really easy to not call a callback and have a test pass, things like that. So I'm already starting to realize a lot of the benefits of the system. Like using native ESM is now like actually speeding up my development environment now that I have the tooling in place. So that's been really cool.
Yeah, it's a good way to kind of showcase how having that one single module format for everyone really benefits the workflow itself. One thing that like Jest, I think, is a really powerful test runner. But if you've ever run into like a caching issue or tried to configure it or like peeked into that kind of plugin ecosystem that they built out, it's a pretty heavy process, especially for front-end developers where, you're building and bundling at the same time as you're then running tests on them. And you essentially have this like shadow build system for a test runner that, again, they do their best to hide from you. But when you need to troubleshoot something, you really have to start digging into, okay, what are they doing to make this code that doesn't run in Node run in a Node test runner?
Yeah.
Everything you've said sounds really exciting, but even just at the most primitive, this idea that like the test runner is a lot of complexity that we don't realize until we really get stuck with a problem that's hard to solve.
And also, you really want to be able to decouple these, right? Like, I think that people have different opinions and really different styles for how they want to write their tests, right? One of the nice things about Mocha actually is that it's a bit more agnostic about this. Like, you can plug different interfaces in for defining the tests. But having a test format that, it's just functions that just throw or whatever, it's just getting this interface pulled in. You can really easily like write a test framework that's just a thing that you import, and then you export your test function. And your test function was actually created by this, library. And so it's not like, oh, I can't use test frameworks now because I have to do them in this format. It's like, no. The format enables you to use like any of these test formats. And like those new test systems don't have to implement like a runner and deal with like concurrency and browsers and da-da-da. So yeah, I'm very curious what you have to say, Chris.
Yeah, no, I was like, this looks a little bit like the old exports interface, which is simply, it require stuff. It's CommonJS stuff, but you export a bunch of tests from a module. And it's not like the stair stepping and nesting suites and all sorts of things. I'm looking at this ES test and it looks like, well, shoot, it would be pretty simple to just whip up a Mocha interface for this, and just now you can run these things. And that would be cool. And I hope you don't mind if I steal it.
Yeah. No. Like if you do that, it would actually really help me because I have a bunch of tests in Mocha that I would love to not have to port, or like some help porting, basically, that would then just work.
Yeah, I'll play with this, and I can probably just publish a third-party interface, and then if people want to use it, then maybe we can, throw it in a core or something. But
awesome,
I'll take a look. Yeah.
That'd be great. Yeah, one of the things to note about it is that, it is pretty new code. There's pretty minimal docs. And the format is really simple. And the runner is also, I think, sort of deceptively small amount of code that has like a lot of implications and features because of the expressibility, if that makes sense. If you look at the runner and the algorithm for the runner, it looks like, oh, it's just kind of this tight little bit of code, but you're not realizing like how infinitely kind of nestable everything is and how a lot of like the after methods and things like actually end up. I'm really into this idea of dynamic test generation. Like most of my tests that I write, like it's a function that creates that pulls in another function that then like loops over things and then generates a bunch of tests for something because I'm often testing with multiple different interfaces and optionality. And so, this was really written in mind, like what is the most minimal set possible that like doesn't have a lot of opinions in it, but doesn't limit the expressibility in what you could actually generate with tests. Really using all the dynamic features that we have in JavaScript that I know and love. So,
yeah, I'd love to give a shout out to Luke Edwards. Has a package called UVU, which is fairly new and I think a little less ambitious than ES test and what you're proposing here, but a really just simple approach to just like let's do a test runner in ESM for Node. And it becomes browser compatible by default. It's really fast. It's not doing all these things that like a Jest would be doing to build and bundle. I've been really impressed by how fast that project is moving as well.
Yeah, one of the nice things about this is that import maps they're a feature that's in Chrome under a flag, so not by default. It's not something that you can really rely upon, so you can't really do named imports in the browser right now. But they are on a flag, and so that means that if you're doing your test in Puppeteer, you can actually like totally rely on this feature without anybody even knowing about it. So that's been awesome. And that's like kind of key to the browser support that I'm working on right now. So this is like the only module that I have that runs in Deno and in Node. And it was very educational to see what it's like to really write code that has no dependencies, that truly has no dependencies on anything else. Like I do some terminal color highlighting and like, had to write all that by hand. And also just to remember how many of the Node standard library interfaces that we're using and rely upon and don't even like think about like aren't in the browser. Like a lot of the things in this runner, like you have to pass in the current working directory and you have to pass in like the standard out interface and stuff because
interesting.
Those are Node things. Like those are Node APIs and you get some of them from compilers, but they're not in Deno, and it's really confronting you with the fact that like, no, you're relying on some Node stuff here. So that was like very educational for me to get that running.
Yeah.
And, I ended up being like pretty impressed with a lot of the stuff in Deno actually.
Yeah. I think that's really worth calling out. I'm glad you did that. Idea that just because now something is ESM doesn't mean it now runs anywhere. Like just, the package can still be using things that are only Node or only browser. One of the things we saw in the Skypack CDN was that we released every package essentially as an ESM interface, which means that Deno can technically load it. But just because it can load it doesn't mean that it can run it by default, right? It can be using something on the file system. It could be a package could be using, again, the crypto library. Like there are all these things that you realize are really baked into how Node works. And just because now it's in a language format that a browser or a Deno can understand doesn't mean that Deno can run the code itself based on how it's written and what it relies on and what it depends on.
We probably got a break soon, but I will bring up that I remember like this had to be like 5 or 6 years ago, but I remember Isaac around the time that he was like deep in sort of maintaining Node.js and kind of being the BDF all the time. He was like getting so sick of all the feature requests coming in that his plan was to start a new node that was just half of the features and just half of everything and call it no. And so because it was both half of Node and it was the answer to every feature request. And I feel like Deno is actually like that a little bit. Like Ryan kind of beat him to it.
Yeah.
Like they're like, no, like these are problems for the platform to solve and the platform hasn't solved them yet. So like go solve them in the platform or solve them on top of the platform and then it'll work for us, right? Like I think that, their approach to package management, they don't have any right now. And I think that their take is that it's not their problem to solve. It's like, it's your problem to solve, actually.
No.
Yeah.
I
Yeah.
Linode is our cloud server of choice. Grab the Nanode plan for just $5 a month, just $5. That gets you a gig of RAM, a blazing fast 25 gig SSD, and 1 terabyte of transfer. Let's be honest, you can go a long ways on that $5. When you do need to scale up, their prices are predictable, so you can put your calculator down. You won't need it. We've been running changelog.com on Linode for years, and we've always impressed by their award-winning support team. Check them out at linode.com/changelog. Once again, that's linode.com/changelog.
Let's get into the thing that people actually care about. Like, I'm building applications. I'm one of the people who build applications and not just libraries like Mikeal likes to mess around with. What do I do? How do I build things? What kinds of benefits are there? Tell me how to do this, Fred, because I actually don't know.
How to build an application with ESM?
Yeah, I just write modules. So you're going to have to tell me how to make websites.
You're in luck because it's 2020 and ESM has been around, 5 years since it was ratified now? Most people actually are writing ESM. At least most READMEs use it as the kind of example code. Most applications almost like assume at this point, as what I've seen from Webpack and Rollup. It's a pretty common workflow. It's that shipping it to the browser that then becomes the thing that we're still moving our way towards as it's become more and more supported in browsers. So really, it's just IE11 that doesn't support this and a couple of other smaller browsers. But it's pretty safe at this point to, at the very least, ship a version of your application that is ESM. And the way that it's kind of recommended to do it now, which is a kind of good going back to your using a deprecated field intentionally to support a kind of both the new and the old at the same time. There's this idea of a type equals module attribute for a script tag, and that tells the browser this is ESM. If it's not here, we won't enable the ESM interface. But then there's also a script with, I don't think it's type, it's just a no module. So no-module. And what that says is like, this is intentionally not ESM. Like if you are a non-ESM browser, this is for you. And so I actually don't know much of the history of it, but it seemed in retrospect like this really smart thing that, okay, it's IE11's coming out. We know we're not going to support ESM. We'll at least support a flag that says, I will run this and I will ignore type equals module. So you can kind of think of it as like a fork. Even the browsers that don't support ESM understand that limitation and won't try to run ESM code. Instead, they'll only try to run code that is like essentially no module. So, oh God, I hope I'm saying this right, but there's essentially this forking. If I'm not, someone please correct me on Twitter. There's essentially this forking mechanism where type equals module is for new browsers. No module is only run on old browsers, and new browsers will essentially ignore it.
And maybe you're getting to this, but it seems to me that most people look at that and they're like, well, I don't want to bundle twice.
Yeah.
That's a pain in the butt. I'm just going to ship the old one and just use that.
And I'm kind of the mind, if you're already in the bundled ecosystem and you don't want to take on that complexity, like that's not the end of the world. It's this really interesting where if you're writing ESM, you're already getting like 80, 90% of the benefits. Your bundler is able to much better understand the code you're writing. You've done your part to enter the new world. What you're missing out on is this idea to kind of drop the legacy requirements that you might have behind you. And what that means is that you can really put all the older, like really old, really heavy polyfills and transpilation only for that second no module bundle. So you can essentially start to target a much more modern ecosystem. And what that means is you get less code kind of bundled, transpiled, polyfilled as a result. So performance is kind of that thing where like if you are happy with what you're doing, it's a nice thing to have. It definitely gives you a better performance score. Google will treat you a little nicer with SEO. It's a good thing to do. But by writing your application in ESM, you're already you're on the elevator, like you're on the path. As tooling gets better and better, and as the ecosystem evolves, you will continue to carry forward those benefits. It's the limbo. You're in the limbo. There's extra work to get out of the limbo. But in the future, by doing that, you are already setting yourself up for success.
Well, and I mean, it shouldn't be underestimated. Like these features really do enable a lot better performance, particularly for applications that are changing all the time, right? Because not every file, not every dependency is changing all that often. And a lot of the code that you're loading one time, you're actually loading every time because of a bundle. Like, there's a lot that people talk about, like, how small they got their bundle and what their bundle performance is and what minification does and which algorithm to use for compression. And like, you're all getting the bundle down and down and down. But like at the end of the day, if loading the entire bundle is the best performance that you will ever have, that is actually still pretty bad. Yeah. Like in an application that you're loading every day and that people are loading every day, like they have all this cache state that they really should be able to benefit from and they can't.
Yeah.
And, like browsers that support this are like a lot of people's mobile phones. Like most mobile phones are running like newish Chrome or newish Safari, like not the newest, but like, new enough that often they do have these features. And so for a lot of, especially mobile people, the first time they load the page, it's going to take, as long as it always did. But the next time they load the page after you updated a couple things, but none of your big dependency bundles, it's going to be really fast.
Yeah.
You're only going to need one of those.
I think that's the much more interesting conversation here, which is what can you do in this new world that you actually can't really do in the old? And there's some things there where it's like, we talk so much about how do we make the new and the old work together. And that's really about kind of supporting the feature sets of both in each other and making that harmonious. But there's also this whole other world of like things only really possible once you have a native browser loading system. And caching is a huge part of that, where once you have a ability, basically letting the browser go back to what it's good at, which is optimizing the things that you load. In today's bundled world, the browser doesn't really know much about what's inside the bundled files, right? It's source files, it's dependency files, they're all mixed together. It's this big soup. And then when you go and make a change, right, you're now having to basically like ship much more code down to the user on their second visit than you would have otherwise had to, because the source code that you changed is mixed with the dependency files that you didn't change, and even the source files that you didn't change. Letting the browser understand basically how your application works and the difference between a source file and a dependency file, lets you then set proper cache headers on the two of them separately. It's two totally different performance stories between a file that changes every time you deploy and a file that really doesn't change that often. It's version tagged, it's pinned, essentially. There's this really cool caching story there where just by default, you get a much better performance story on second, third, fourth visit, where files only need to be re-downloaded when you've actually changed them. Versus the world today, where every time you redeploy, you essentially set a new hash, it all gets cleared out, and your user is stuck downloading on a second and third visit, essentially the whole app over again.
So I really want to hear more about Snowpack, because again, I don't write enough websites to use it, but I'm like super interested in it. Say I'm a Webpack user. I write my app, and Webpack is doing all this buildy stuff, and I have this browser up that's things are updating all the time. What is the difference in kind of the development story? First and foremost, like what does that development workflow look like, and what are some of the trade-offs that might be there? And then, after that, then you talk about the distribution story and how that actually gets packaged up into an application.
Yeah, definitely. It's one of those things where you really feel it instantly when you use it. So the first thing I'd say is just try it out. Try one of our templates. So we have a create Snowpack app that lets you just kind of get started with something smaller. We also are, essentially our goal is to be a drop-in replacement for Create React app. So because Create React app is a pretty controlled environment, we can actually do our best to be a drop-in replacement. They don't allow a lot of customization. So it's not a moving target. It's one that we can kind of pin to. So if you have a Create React app template, I would also say just try to run that in Snowpack.
You have stuff like that for Vue too, right?
Yeah, we have templates for all of these and official plugins to support the building. The reason I say just try it and see how it works is because what you get is essentially a 50 millisecond startup time, where instead of having to do any upfront work, we're following this model where we only need to build things as they're requested. So you run, your npm start or whatever you do to start your dev server, and finger snap, it's there. The way that works is that because all we're doing is really setting up the server, that startup time there's nothing to do, right? We haven't seen you request a file yet. What that does is then that, you open your browser, you go to the dev site, and now all of a sudden the browser is telling the dev server, hey, I need these files.
And a lot of those files don't need to be compiled, right? A lot of them can just be loaded.
Yeah, exactly. So if you're just writing JavaScript, plain old JavaScript, you're not using React, you're not using TypeScript, we're essentially just piping them, it's a pretty light dev server. And then where we come into play and where we start to match the world that you're used to, the Webpack, the build compiled world, is that we will then take a file like a TypeScript file, a Svelte file, a Vue file, and as it goes through that pipeline from the dev server to back to the browser, we will just build that one file. So instead of this really complex, the world that I've seen is of the bundle development, you're trying to define a build that you never actually see really interacting. You only see it kind of wrapped in this big black box, which is a bundle. What we get is a much simpler, the file that you load in the browser is a one-to-one representation of the file on disk. So debugging becomes a lot easier. You don't really need source maps. They certainly help still, but you look up an app.js file and it matches your app.svelte file kind of one-to-one, just the compiled version of it. Versus what I've had to do with a bundled application is I found an error. I click into that error. I have a 10,000 line JavaScript file that I'm now trying to map back to a source file where the error happened. Source maps help, but then that's its own can of worms.
Fred, what about non-script assets?
Yeah. So are you saying an SVG or a WASM? CSS?
Yeah, well, sure. Okay, so CSS, say, maybe you want to write in Sass. Will it go and it makes CSS out of that?
Yeah, that's a great question. So it's interesting. We tackle that as if it's any other built asset. So what's interesting about this world that we're moving into, where ESM is relying on what the platform and the browser can do, all of a sudden the tooling, by being lighter touch, is also a little more flexible in how it treats what it's building, right? Instead of I am building a JavaScript bundle, the Snowpack story is more I am building your web application. And that means we need a story around CSS, images, SVG.
Mm-hmm.
So it's all configurable through our build system. It's essentially a build system for web apps. So you can think of it a little bit more like 11D in that way, where it has all the power of building a JS app.
So yeah, that's where I was going. I was going to 11D. I was like, okay, what if I ask for Markdown?
Yeah.
Will it go and compile that Markdown? Or will it go and call out to 11D or whatever, right?
Yeah, that is something that we haven't tackled yet, because what 11D does, they talk about it like it's this really simple system. There's some complexity in there. But what we do is we have an 11D starter template and an 11D plugin, where essentially what we're saying is through Snowpack as the build system, the thing that you run npm start and npm build, and you you build your application with Snowpack, we can still run commands through that process. We can say, okay, I am a plugin for Snowpack, and what I do is I run 11t to build your application. So it's this flexible model where we're taking on the idea of serving files and building your application, but on a much more holistic level where you can start to connect tools like Sass and 11d into this, just a build runner essentially that is Snowpack. So in the way that Webpack is really, it's like a very SPA model where you're bundling things together and trying to learn the whole scope of a website as it's represented by JavaScript. What we're instead saying is that your application is your application. It is many things. It's JavaScript, it's CSS, it's images. And what we do is we one-to-one build those. We let you connect the tools you like, and our end result is not a JavaScript bundle, it's a website. So it's really like a website builder versus a JavaScript builder. And because ESM is lighter touch and the tooling is lighter touch, we're able to handle everything that you love about a bundled builder for JavaScript, but in the context of you're just building an application. You're not building JavaScript specifically.
Mm-hmm. No, I'm going to play with that.
So yeah, we have Sass plugins, we have 11d plugins. It's this really cool model where for a long time, single page apps have been like the blessed way to do development, and tooling kind of assumes, Create React App assumes you're following that model. But what we're able to say is a single page app is one thing that you can build. If you really want to build JavaScript focused, JavaScript only, CSS and JavaScript, if you love that JavaScript world, we handle that. But if you're trying to build a multi-page app, you're trying to build something that's a lot closer to what a website used to be, which is HTML, CSS, and JavaScript all treated equally, you can do that as well. Our current website is built with 11d and Snowpack together, and they work pretty well together.
Well, I'm going to give it a shot. That sounds fun.
Yeah, it's a lot of fun. I'd say fun is kind of the word we're going for. Just like realizing how much we've been slowed down by the generation of tooling. Where again, I feel like Webpack, Rollup, everyone who got us to where we are today, we wouldn't be here if it weren't for them, right? This idea that we can all share one ecosystem of packages, and that something written will run on both Node and the browser with tooling. That's still an accomplishment, and we're just kind of the next iteration. So we get to leave behind some of the legacy. But I totally realize that how we got here is by standing on the shoulders of those giants and all the work they've done over the last 10 years.
So obviously, I can use this, and when I'm not running a dev server, I can just compile it all out, and I'll get a bunch of files, and I can push them into GitHub Pages or whatever sort of static site to host. But we've been talking about there's a lot of new deployment stories and new opportunities in this new ecosystem. So I think we should think about talk about some of the other distribution stories for an application, and also get a little bit into is there anything that we can do to make the legacy part of that a little bit easier? Like you talked about how there's this no module thing, and how do I automate filling in that old no module thing for old browsers and stuff like that?
Yeah, I think we're closer to this whole episode I feel like has been how do you deal with legacy? How do you transition very large changes in a comfortable way? Again, I feel like for the first time, the web is actually in a pretty lucky position here, where IE 11 is getting end of life pretty soon. It's kind of up to what that distinction is, but their general mainstream support, I think, ends in October of this year, which a lot of people don't realize. So sure, you might have some larger enterprises getting kind of an extension with Microsoft. And that still matters if you're like a Salesforce, where most of your customers are these larger enterprises. But if you're building a general application for a general user, all of a sudden that user is not on IE 11 anymore. Or it's very rare that you really have that requirement anymore. So I think by waiting for October and waiting a little bit longer, a lot of these problems on the web solve themselves. A lot of the legacy just kind of melts away. And then that idea where it's always harder to support both at the same time, you can kind of just start to build for that world. And the world we're entering on the web is really exciting, right? It's every browser is essentially following this evergreen model now, where updates are sent automatically. Even enterprises are encouraged to update regularly. It's this really nice model where now all of a sudden you can start to build for a much more modern platform. It doesn't mean right when a new feature is launched in Chrome or in Firefox that you can start using it everywhere. There's still obviously a little bit of onboarding of those new features, but your lowest common denominator is suddenly only a few versions back. So there's a really exciting model that's happening there as well. That change is actually going to be pretty influential for not just how you can build for the web, but what you can assume your users are able to use, and then not having to always find a really low common denominator to support them. It's specific to Snowpack. It's one of those interesting things where we now get this option to build and serve an unbundled application. So if you're again, this idea of default complexity versus default simplicity. Right now, if I'm building a web application, I need a bundler, right? Or I'm so used to saying right now. Really, I mean, in the old world, you needed a bundler to work with NPM. And that means you need all the complexity that comes with how do I configure this bundler? What plugins do I need? The model that Snowpack is following is that by default, everything should just work. Everything should just work in a way where you don't need to do a lot of configuration to get an application that runs. Instead of bundling being an assumption and a requirement, it's now just an optional thing that you can do for performance. And that's, again, we're taking the old and the new and trying to grab the best of both of them, where bundling is an optimization at the end of the day. It's only in the last 10 years that it became this requirement that we all had to build on top of. But really what it is we're saying, I want to combine multiple files together to speed up my site. That's a much different model from I need to do this for anything to run for anyone. So the whole model is kind of flipping, and that complexity is now something you go out and find because it solves a problem, versus it's baked into the very foundation that you need to get started.
So what's SkyPack doing then? If this is all just handled and I can push static resources, what does SkyPack do?
Yeah, SkyPack is our next kind of step into this kind of, okay, now that we have this, what do we do with it, and what's new and only possible with this model? SkyPack is, if you've heard of the Pika CDN, that was our first version, and this is essentially the production-ready version of that, where if you think of what Snowpack's doing and what makes it so special, it takes an NPM package and all the files and all the complexity and all the legacy stuff, it turns it into a single JavaScript file that can be loaded via ESM and run in the browser. SkyPack is that idea taken to the CDN, where instead of a CDN being a thing that serves files out of packages and individual things, SkyPack is a way to load a package, and any package name that you give it will be loadable as ESM. So even if it wasn't written as ESM, we as a CDN do the work to convert it and compile it into ESM. So essentially, we give you a unified interface to load any package by name from our CDN, and we do all the work to make that work really well in your application. Part of it is just building out this platform so that anyone can use it. If you're building tooling, you can start to pull from it. If you're building an application, you can kind of get rid of any building at all and just load dependencies on demand. We see it as a really interesting model where now you're hosting code from the CDN that is thinking in terms of packages, and it's optimizing in terms of packages. So going back to that caching story, we can cache dependencies really well because they're versioned and they're cut and they're done. So once you load a dependency from SkyPack, it is essentially locked forever. We send back the cache header so that you only ever load it once in your browser, and the browser will cache it forever. It's all these things that you can really only do with an ESM system, where the browser is now able to go back to what it does best of the optimizing your files and understanding your cache state, versus really realizing what the older tooling was doing was trying to replicate that functionality and essentially taking on the responsibility that the browser is just naturally better at. So the caching story for SkyPack and building on top of it is really, really cool.
That's awesome.
Yeah.
That's really cool. I'm very excited. This is a good looking space.
Yeah. So it's one of those things that just powers, it can power so much of what has traditionally had to be tooling dependent. It can suddenly just load code dynamically on demand as needed. It really is an interesting performance story.
Chris, any final thoughts before we close it out?
My mind is empty.
Now I just want to know what repos Mikeal has private.
I meditate for hours to empty my mind. So I meditate for hours to empty my mind. I'm jealous that it happens so quickly for you. This is a difficult state to enter. Yeah, I mean, I write modules. Like, that's what I do. It's okay. It's nothing special. All right, awesome. This is a great show. I think that we really got into ESM. I think I did an ESM show on JS Party 9 months, maybe a year ago. And it was a little bit you can't use this yet. I'm sorry.
A lot has changed in 9 months.
Yeah. And now it's actually, if you're writing applications, it sounds like it's really ready. You're good. Just write web apps in it. If you're writing libraries, it's still a little tricky, but I think that the tooling is getting there now. If you're a little more comfortable dealing with that, it's ready for you as well. And like so many things in JavaScript that I was resistant to, but fully wrong about, ESM is also one of those things. I was very down, why are we breaking the ecosystem for this? It's just, who cares about the syntax? And now that I'm in the guts of it, I can see there are some really big advantages. People really should move to these patterns. They are better. Let's just do it. All right. Great show. Great talking with you. That's all.
Thanks to Fred for coming back on the show, to Mikeal for making it all happen, and to Chris for rounding out the panel. Thanks also to you for listening. We appreciate you. If you love JS Party, listen up, I have some semi-secret news to share. We're beta testing a membership program that lets you get closer to the metal. It's called Changelog++, and this is the first time we're talking about it publicly. Support our work, help us test out this program, and make the ads disappear at changelog.com/++. Once again, that's changelog.com/++. JS Party is brought to you by awesome sponsors. Thanks to Fastly, Linode, and Rollbar for their continued support. And our music is provided by the mysterious Breakmaster Cylinder. That's all we have for you this week. We'll talk to you next time.